Let's look at our first word problem. Here we have the following. If y varies as x and y equals 18 when x equals 5, find the value of y when x is equal to 20 over 23. This is called a direct variation problem because one of our variables is varying directly as the other one changes. Now, the key phrase you're looking for in these variation problems is right here. Y varies as x. When you see that phrase, you write the equation of variation, y is equal to kx. K is called our constant of variation. It's going to remain the same throughout the problem. So our first step in solving these variation problems is to find out what is k. So how can we find k? It says y equals 18 when x is 5. So we're going to use these two facts. The first step again, write the variation equation. We're going to solve for k. So when we do, y is 18, k is what we're looking for, so we leave it in our equation. X is equal to 5. To solve this equation for k, simply divide both sides by 5. So k is equal to 18/5. So we found our constant of variation to be 18/5. We're going to take this value and put it into our variation equation, and our new equation is y is equal to 18/5 x. Now, all I did again, here's my equation of variation. I get this from the statement right here, y varies directly as x. It's a direct variation. Y is 18, x is 5. I find my k value, that's my constant of variation. I take the 18/5, substitute it in for k, and my new equation of variation for this problem is y equals 18/5 k. Notice all we did here was replace k with the found value 18/5. Now notice we still haven't answered the question asked. It asks us to find the value of y when x is equal to 20/23. So that simply means taking the 20/23 that x is equal to and substituting it into our equation of variation. So that gives me y equals 18/5 times, and in place of x, we're going to substitute the value 20 over 23. Now again, this boils down to some basic arithmetic. In this case, we're multiplying some fractions. So let's go ahead and divide out common factors. 5 goes into 5 one time. 5 goes into 20 4 times. So my y value is going to be 18 times 4, or 72, all over 1 times 23, or simply 23. So have we asked the question, have we answered the question that was asked? Have we found the value of y? Yes, we did, when x was equal to 20 over 23. Now again, the key when looking at these variation problems is you're looking for this phrase, y varies directly as x. When you see that phrase, you should automatically write y equals kx. The first step is to find the value of k, the constant of variation. Rewrite your equation of variation, y equals 18/5 x, when we find that constant k. Then you'll be able to answer the question that was asked. Now let's look at our next problem. A certain type of car has stopping distance that varies directly as the square of its speed. If this car is traveling at a speed of 20 miles per hour on an ice-covered road, it can stop in 60 feet. If the car is traveling at 40 miles per hour on an icy road, what will its stopping distance be? Now that we've read our problem carefully, let's see what we have to do to solve it. Well, the key to this problem was the statement, the distance varies directly as the square of the speed. When you read that statement, we get the equation of variation, d equals ks squared. Again, d is standing for our distance of stopping, and s stands for the speed of the car. So this is the key equation for this particular equation. Now, just as we did in the first problem, we need to solve for our constant of variation, k. We know that distance is 60 when the speed is 20 miles per hour. 60 meaning 60 feet. So with the distance of 60 feet at a speed of 20 miles per hour, knowing these two facts will allow us to solve for our constant of variation, k. We're going to make the substitution. We're going to let d equal 60. We're solving for k, so we're going to leave that in our equation. S is equal to 20. That's the speed. And notice that is squared as well. Now that we have this equation, we can easily solve for k. 60 is equal to k. 20 squared, or 20 times 20, is 400. Remember, our goal is to solve for k, so we're going to divide both sides by 400. When we do, dividing by 400 gives us k is equal to, now we'll reduce the fraction and we get 6 over 40 when we divide out those zeros. And to reduce the fraction 6 over 40, that reduces to 3 over 20. So what does that tell us? That tells us that our constant of variation is equal to 3/20. Once we find our constant of variation, we take this value and substitute it back into our equation of variation. So let's work with that. We're going to take the k equals 3/20, substitute it into our equation of variation. So d is equal to k, which we found to be 3/20, and s squared. Now that we have our equation of variation, we're ready to answer the question that was asked. Remember, in this problem, they're asking us to find the distance d when the stopping speed, or when the speed is equal to 40 miles per hour. Let's write that down. So we want to find now the distance d when the speed of the vehicle is 40 miles per hour. Okay, so how do we find d if we know the speed is 40 miles per hour? Well, since we already found our constant of variation k to be 3 over 20, all we have to do to solve for d is to take the speed, 40 miles per hour, and substitute it into our equation of variation. So the distance d that it takes the car to stop on this icy road is 3/20 times s squared. S we found is given to be 40. So we need to find d when s is equal to 40 miles per hour. So basically we just have this small calculation, 3/20 times 40 squared, 1600. When we do the multiplication, we'll find out here that the distance d is equal to, all we have to do is divide 20 into 1600. I divide out the zeros, and then I know that 2 divides into 160 80 times. So 3 times 80 is 240. So what is this telling me? That's telling me that the distance it takes the car to stop when it's traveling along an icy road at 40 miles per hour is 240 feet. Remember, originally, we knew that the car was traveling at 20 miles per hour along that same icy road. It took 60 feet to stop. Now at 40 miles per hour, it takes that same car 240 feet to stop.